The largest planet in the solar system is not only known for its colossal size, but also for its numerous storms that rage on its surface. These storms can last for centuries and reach speeds of up to 618 miles per hour. One of the most famous storms is the Great Red Spot, which has been observed since 1664. But what causes these storms and why do they last so long? And what makes the Great Red Spot so unique? To understand Jupiter's storms, we first need to look at the planet itself. Jupiter is a gas giant, meaning it doesn't have a solid surface like Earth. Instead, it's made up of swirling gases and liquids, mostly hydrogen and helium. These gases are in a constant state of motion, and it's this motion that creates Jupiter's iconic bands of clouds. The different bands of clouds on Jupiter are separated by narrow dark lines called belts and light-colored zones. The zones are regions of rising gas, and the belts are regions of sinking gas. Where the two meet, there is a lot of turbulence, and this is where the storms form. Now let's talk about the Great Red Spot. This storm is located in the southern hemisphere of Jupiter and is so big that Earth could fit inside it with room to spare. The Great Red Spot is a high-pressure storm, which means that the gases in the storm are rising rapidly. As the gases rise, they cool and form clouds. The clouds are red because of the chemical composition of Jupiter's atmosphere. As the sun's ultraviolet radiation breaks down ammonia, it forms reddish-brown compounds that make the clouds appear red. The Great Red Spot has been around for at least 300 years, and it's still going strong. But how does it stay that way for so long? Well, it turns out that Jupiter's storms are powered by the planet's internal heat. Jupiter radiates more heat than it receives from the sun, and this heat comes from the planet's core. Scientists think that Jupiter's core is a gigantic ball of metallic hydrogen. And when this hydrogen is squeezed by the immense pressure in Jupiter's core, it creates a magnetic field that generates electric currents. These electric currents then produce heat. And here's where things get interesting. The heat from Jupiter's core creates convection currents in the atmosphere. Convection currents are the same thing that happens when you heat water on the stove. When you turn on the burner, the water at the bottom of the pan gets hot and rises. While cooler water from above sinks to the bottom to take its place, this cycle continues and creates a convection current. The same thing happens on Jupiter, except instead of water, it's hydrogen and helium. The convection currents create the rising and sinking motion that is needed to form the storms. But why do the storms on Jupiter last for so long? Well, it turns out that Jupiter's atmosphere is very stable, which means that the gases don't mix very easily. This means that once a storm forms, it can continue to rage for hundreds or even thousands of years. But the Great Red Spot is not just any ordinary storm. It's an anticyclone, which means that the air is rotating in a clockwise direction. Most of the storms on Jupiter are cyclones, which are rotating in a counterclockwise direction. The Great Red Spot is the only major anticyclone on the planet, and scientists are still not sure exactly why it's an anticyclone. The Great Red Spot was first discovered by Italian astronomer Giovanni Cassini in 1664. At the time, it was much smaller than it is now and was oval-shaped. Since then, the storm has grown and changed shape several times. In the 19th century, it became round and reached its maximum size. Today, it is once again oval-shaped and getting wider. The speed of the winds in the Great Red Spot is another reason why it is so impressive. The storm can reach speeds of up to 618 miles per hour, which is faster than the speed of sound. These high speeds are caused by the strong pressure gradient in the storm. Pressure gradient simply refers to the change in pressure over a distance. The greater the difference in pressure between two areas, the greater the pressure gradient, and the stronger the winds will be. In the case of the Great Red Spot, the pressure gradient is so strong that it creates winds that blow around the storm at incredible speeds. While the Great Red Spot is impressive, it's not the only storm on Jupiter. Jupiter has many other storms that are just as violent, including the White Spot and the Little Red Spot. The White Spot is a high-pressure storm in the northern hemisphere of Jupiter and is almost as big as the Great Red Spot, however. It is not as well known because it is not as long-lived. The White Spot has only been observed for a few years at a time and then disappears for several decades. The Little Red Spot is a smaller version of the Great Red Spot and is located nearby. It is not as large or as long-lived as the Great Red Spot, but it is still an impressive storm nonetheless. The storms on Jupiter are not only fascinating to watch, but they also provide scientists with valuable information about the planet's atmosphere. By studying the storms, scientists can learn about the composition of Jupiter's atmosphere and the planet's internal heat. This information helps scientists better understand the formation and evolution of the planet. In recent years, scientists have been able to get even more detailed information about Jupiter's storms, thanks to the Juno spacecraft. The Juno spacecraft has been orbiting Jupiter since 2016 and has provided stunning images of the planet's atmosphere. One of the most impressive images captured by Juno is a close-up view of the Great Red Spot showing its immense size and swirling clouds. The spacecraft has also measured the temperature and pressure in Jupiter's atmosphere, providing valuable data for scientists studying the planet's storms. The data from Juno and other spacecraft have helped scientists better understand the dynamics of Jupiter's storms. For example, scientists have learned that the storms are not static, but are constantly moving and changing. They have also learned that the storms are not isolated events, but are connected to each other in a complex system. Despite all the progress that has been made in understanding Jupiter's storms, there is still a lot that scientists don't know. For example, scientists are still trying to figure out why the Great Red Spot is an anticyclone and not a cyclone like most of the other storms on the planet. They are also trying to understand the role that Jupiter's internal heat plays in the formation and longevity of the storms. In the future, scientists hope to learn even more about Jupiter's storms and their impact on the planet's atmosphere. By studying these storms, scientists are not only expanding our knowledge of Jupiter, but also gaining a better understanding of the dynamics of storms in general. So next time you hear about a storm on Jupiter, remember that it could be one of the most violent and awe-inspiring natural phenomena in the universe. Thank you for watching. If you enjoyed the video, please subscribe and leave a comment below with your thoughts or suggestions for future videos. And we would love to hear from you. Until next time, keep looking up.